How many of you are interested in family history? Everyone's raising their hand. So I'm Peter Roberts, and I always thought that boys were made out of puppy dogs' tails and things like that. And I was very jealous that my sister was made out of sugar and spice. But now I know what we're really made out of, and that's DNA. This is an actual microscopic image of the X chromosome and the Y chromosome, and the Y chromosome is what you see on the bottom right. And who here has a Y chromosome? Who has a Y chromosome? Raise your hand if you've got a Y chromosome. Only all the males should be raising their hands. You've got Y chromosomes, okay? Who here has mitochondrial DNA? Okay, everyone raises their hand. Everyone, males and females both have mitochondrial DNA, but only women pass it on. And who has autosomal DNA? Everyone's got autosomal DNA. This is an image of autosomal DNA, and then in the bottom right, you've got the X and the Y chromosome. And who has X chromosomes? Everyone's got X chromosomes. Females have 2 copies, males have 1. And there are 4 types of DNA that are useful for genealogy: the Y DNA, mitochondrial DNA, autosomal DNA or AtDNA, and then X DNA. Y DNA is also known as the Y chromosome, and it reveals your direct paternal line. That's your father's 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 father. The Y DNA is passed virtually unchanged from a father to a son. If this were your ancestry here, you can see your father's line goes up on the left side, and your direct maternal line is on your right side. And you can see all the different branches of ancestry that contributed to your DNA. Your Y DNA is only looking at that direct male line. We're only going to be seeing matching going on with ancestors that are on this direct line of your ancestry with a Y chromosome test. Mitochondrial DNA reveals the direct maternal line, one's mother's 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 mother. Mitochondrial DNA is passed virtually unchanged from a mother to her children, both males and females. So if this is your ancestral tree, then it's just this portion, the right-hand side, that is going to be, you're going to find matches with on your direct maternal line. Autosomal DNA is useful usually within the last 5 generations, but for populations like the Bahamas, it's quite often useful for the last 7 generations because a lot of the cousins tend to marry each other. And this is a 7-generation chart. Autosomal DNA is helpful with your ancestry from all of those various branches on all lines of your ancestry. Now with the X chromosome, there's a different inheritance pattern. If you're male, you only got an X chromosome from your mother. The X chromosome is not passed from a father to a son, it's only passed through a daughter. And so on the right-hand side is a female's X chromosome inheritance. And you can see the light shading. On the left-hand side is a male's X chromosome inheritance. And wherever you have a father-son in your ancestral tree, you can chop that branch off of the tree because they could not have contributed to your X chromosome. And that's very important when you find an X chromosome matched with somebody else. You know that that shared ancestor could only have lived on a particular part of your ancestral tree and a particular part of their ancestral tree. One caveat about DNA testing is that the DNA results are only as good as the database that you're comparing with, or the population that was sampled. And the results are inferred, meaning that it's based on some reasoning going on. And also, quite often you might take a DNA test and it shows that you are matching up with a particular ethnic group. The results are not saying that you come from that ethnic group. What they're saying is that you share ancestry with that ethnic group. In some cases, the shared ancestor may have lived prior to when that ethnic group existed. That's especially the case with mitochondrial DNA, which can be you can match on mitochondrial DNA, and the ancestor can be quite old. There are 3 different major DNA testing companies, Family Tree DNA, which is useful because it tests Y chromosome and mitochondrial DNA, as well as autosomal DNA. And then there's also Ancestry DNA, which does an autosomal test, and 23andMe, which does an autosomal test. And the Bahamas DNA Project is using results from all 3 labs. You order your test over the internet or by telephone, and the price is about $150 for a direct paternal line, $70 for a direct maternal line, and about $100 for an autosomal DNA test, which includes the X chromosome. And this is what a DNA test looks like. Basically, it's a cheek swab where you rub inside of your mouth on one side for about a minute, and then you use another swab and you rub on the other side of your mouth. There's also no blood involved, and that's what kept me from testing for a long period of time, because I thought I had to draw blood. But it's a painless test, and then you mail your vial back to the lab, and in about 2 months you get your results. And then now we're going to talk about how to understand what the results mean. When I found this cartoon, I thought it was really funny, but when I show it to people, they quite often don't laugh. But anyway, I thought it's quite hilarious, because my wife's not interested in my Y chromosome at all. The Y-DNA results are the most helpful for genealogy and the easiest to use. When you get your results, you may have taken a 12-marker test, a 25-marker test, or a 37-marker test. This is an example here of a 25-marker test, and what you need to pay attention to are those 25 numbers. The 13, 25, 14, 10 numbers that you see there, that's a haplotype. The string of 25 numbers is a haplotype. You want to compare those 25 numbers with other people's 25 numbers. That's how you determine whether 2 males share the same direct male line ancestor. And this is a case where 2 people with the same last name of Eldon are matching on 24 out of 25 markers. It's virtually certain, the fact that they both come out of the Bahamas, they've got the same last name, and that they're matching 90% of their markers or closer, it's virtually certain that they share a common ancestor with that surname. And this is a case with mitochondrial DNA. The results look a little bit different, but normally you have to have, instead of a 90% or better matching, you almost in most cases, you have to have 100% matching. There are exceptions where you can have 1 marker off or even 2 markers off, but almost in all cases, you're looking at an exact match. So this is a case where the earliest known ancestor is an Amelia Ambrister, and then you've got a Julia Knowles. The descendants of those 2 women have got exactly matching mitochondrial DNA. If we could extend the ancestry of Amelia Ambrister and Julia Knowles, they would eventually, on the direct maternal line, they would connect in the Bahamas, quite likely. Now, it's autosomal DNA from where we get how we look, mostly. But autosomal DNA is also very helpful for finding ancestry. And the key thing to be concerned with is that it's matching of segments on different chromosomes, and when 2 or more people match on the same, they overlap or they match the same segment, that's where you want to pay attention to. And this is an example of one person. You can see on chromosome 4 that there's 2 segments. What we have here is one person, the tester, matching 2 other people on that segment on chromosome 4. The question to ask whenever you see that type of overlap is, do those 2 people who overlap, do they match each other? The fact that the tester matches them is, the tester has 2 copies of chromosome 4, and each of the testers has 2 copies of chromosome 4. The test lab cannot tell you whether or not it's on the same copy of chromosome 4 for all 3 of them. You have to ask the other people, do they match each other? That shared segment, assuming they all do match each other, that same segment is coming from the common ancestor of all three. If there was an overlap of 4 or more people, then it's the common ancestor for that whole group. The larger the size of the segments and the greater number of segments that you share with somebody is an indication of the closeness of the relationship. In this case, the orange-colored segments here, it's between myself and my aunt. And so this is how closely an aunt and a nephew match. And there are tools to help you figure out whether or not your matches are matching each other. This is one tool is called DNA GEDCOM, and what you can see is all of your matches and who they match. The colored rectangles that you see here, those, the larger groupings, where on the right-hand side you can see that there's overlapping going on of it. They're stacked like pancakes above each other. And that's what you want to pay attention to, and then you can see that in the rectangle that they're all matching each other. And so what you would do is that everyone in that group that you have the large rectangle, you would email everyone in the group and say, we're matching on this same segment. What is your ancestry? Here's mine. And then that's how you're able to, in a sense, find out how you're matching other people, and then you can work together to find if one of them has more ancestry than you do on that particular line. The same thing is another very popular site called GEDmatch. Both of these sites are free, but you can also see in the green parts here, you can see what they call triangulated groups, where your matches are matching each other. And those are the people you want to contact and say, here's our, what ancestry do you have? Here's mine. Try to figure out what we have in common. We're going to switch gears a little bit and talk about some of the success stories of the Bahamas DNA Project. For many years, a number of the Bethels with one L believed that they were not related to the Bethels with the double Ls. And so we've done DNA testing of a number of Bethel lines, including ones with single L's and double L's, and they all match each other. And most importantly, they also match with surnames associated with Clan MacLean of the Isle of Mull in Scotland. And so it seems quite evident, because of this, the numerous number of matches that they have, that if you have Bethel ancestry, then you can say that you have clan members associated with this castle in the Isle of Mull, because this is the castle of the chief of Clan MacLean. The Olbrey family in the Bahamas can only trace its ancestry back about to an unbroken genealogy back to probably about the 1760s or so. And there was a story that's been published about 100 years ago about the Olbrey family. There's an Olbrey family spelled Albree in New England. And they have a story of their ancestor surviving an attack in Nassau in the late 1600s. And they were transported to Boston, the area around Boston. And they also brought this clock with them, a weaver's clock. And that family has a line of descendants living today, and that Olbrey, Albree, took a Y chromosome test, and they matched up with the Olbreys in the Bahamas. They also have an ancestry going back before the Bahamas to Bermuda, and then back to England at this particular location that you see on the map, a farm in England. So even though that the Olbreys in the Bahamas don't have a genealogy going back to England, because they match up with an Olbrey family that came from the Bahamas, that does have an unbroken line, then we can say that this is connected. And they also have another, through their ancestry, they can connect with all of the noble families of Europe. Conrad Pennybaker was a Fife Major in the 4th Virginia Regiment, fighting for during the American Revolution against the British. He was captured in 1780 in Savannah, and it was assumed that he died because his widow and his heirs filed claims after the Revolutionary War. A year later, pay records start for a Conrad Pennybaker, the same name, and he's a drummer for the British King's Rangers. And the last pay record for him is in 1783, when the Loyalists were evacuated to the Bahamas. And so at Great Guanakee, we have a Conrad Pennybaker, and his Conrad, I believe it's either Conrad or his son, changes the surname to Baker, and Baker's Bay is named after Conrad Pennybaker. The descendants of the Loyalist Conrad matched the descendants of the Revolutionary Conrad. And so the Revolutionary descendants can trace their line back to a Penny Becker born in Germany in 1674. And so here we have a situation where you've got penny backers matching penny packers, matching penny bakers, and matching baker. And also you've got a turncoat bigamist who is the ancestor for a lot of Bahamian families. Gideon Lowe was born about 1720. He's the father of Captain Gideon Lowe, born about 1753 in Harbor Island. The closest matches that he has are in Mexico, northern Portugal, central Portugal, Brazil, Tanzania, and this borders Portuguese East Africa. Prior to testing, I'd always assumed that the Lowes were probably descendant from somebody from the British Isles. This indicates probably that it's more like the Iberian Peninsula, Portuguese or Portugal or Spain. And also the type of Y-DNA basically points to the fact that it could be Sephardic Jewish. And we know from history that Jews were expelled from Spain if they didn't convert. We know that a lot of Jews became conquistadors, and so it's my speculation that the ancestor of the Lowes in the Bahamas may be descendants of these Sephardic Jews, one of these Sephardic Jews that left Iberia shortly after Columbus sailed. How this all started was I was interested in my Roberts family, and my great aunt had told me that all the Robertses were from all the Robertses except ours were one family. Our Roberts family was not related to the other Robertses of the Bahamas. And I didn't quite believe this, and when DNA testing came about, I found some Robertses that had gone to Key West where my Robertses had gone, and I did some testing of them, and I did some testing of myself, and they didn't match me. And then I tested another Roberts, and they didn't match. I tested another Roberts, and they didn't match. And I started to wonder, am I really a Roberts? The earliest record of a Roberts is in 1717 when 3 pirates were pardoned. I've always wondered, am I descendant of one of those pirates? Eventually, I did find some Robertses that I matched with, and it turns out we've tested about 20 different Roberts families. Half of them belong to what we call the IZ59 group, and the other is a type of Y chromosome called RL20. And 2 different types of Y DNA, 2 different Roberts families in the Bahamas, living in the same islands. Now, what I found interesting is that my closest Y chromosome match was with the Murray, living currently in South Africa, and he traces his Murrays to the Murrays of Scotland, which is the same line as Lord Dunmore, which was governor of Harbor Island back in the time when my Roberts family was in Harbor Island. So I'm suspecting, am I a descendant of one of the pirates of the Bahamas, or am I a descendant from Lord Dunmore? But truth is, I really can't confirm that the Murray connection is in the Bahamas or if it's in Scotland. The Roberts line is associated with Clan Donachie, which is in Perthshire, Scotland, It's also the neighboring clan of the Clan Murray, and so anyway, I'm suspecting that I'm really a member of Clan Murray, even though I became a life member of Clan Donaghy before I knew this information. And anyway, so what I've recently discovered is that I'm probably descendant from both Robert's lines on another branch of my Bahamian ancestry. And so right now I'm trying to determine whether or not statistically I can say that I'm a descendant from a pirate. The Griffins can certainly say that they are descendant from the Norse Vikings. The Griffins of the Bahamas, they belong to a type of Y chromosome which is considered ultra-Norse. And these are the areas of the British Isles that were settled by the Norse Vikings. And if the Griffins truly are from the British Isles, then we can say that their ancestors from one of these shaded areas. And that prior to that, they were in Scandinavia. The Sweeting family of the Bahamas, and also the one of the Johnson lines from the Bahamas. There are 3 different Johnson families in the Bahamas. They have a type of Y chromosome that is almost virtually found in the Balkan Peninsula. And how that got to if they are from the British Isles, then it's most likely from a Roman soldier, because there are records showing that there were Roman soldiers from the Balkans in the British Isles. A number of people of African descent have also taken Y chromosome tests, and these are some of the surnames there. There's 2 different Adderley families, 2 different Brennan families. These surnames, they're matching up with people from these various ethnic groups in Africa. And that's one of the wonderful things, that there are no historical records that tell you where you may be from, but this gives you an indication. As I mentioned earlier, it doesn't prove that you are from that ethnic group, but that you share ancestry with that ethnic group. Early on, we did Y chromosome testing of Wyannie Malone, descendants of the sons of Wyannie Malone. And a large 500 page book has been written about the descendants of Wyannie Malone. And we were really hoping that the sons of Wyannie Malone, their descendants, their very distant cousins, that they would match each other on the Y chromosome, because we didn't necessarily want to prove this whole book to have some false information in it. Thankfully, they did match each other. The 3 different descendants of different sons of Wyannie Malone all match each other. But what if they didn't match? About 3 to 5% of the various populations do not have the father they believe is their father. So in this audience, there may be a few people where your daddy isn't your daddy, but your daddy doesn't know. Also keep in mind, back in 1701, there's a record of Governor Haskett reporting that there are only 20 lawfully married couples in the Bahamas. And so given the harsh conditions, thinking about children being adopted by other family members, it's quite often that a son might not end up with the same surname as the father. There's quite often when somebody takes a mitochondrial test or a Y chromosome test, they can trace their ancestry further back prior to the Bahamas. It's not always the case that we can be specific about where you're coming from, but this is an instance where my brother's wife's father's direct female line traces back to a river in West Africa. And every marking that you see there is one person from a survey of the mitochondrial DNA of Africa, and this is where that type of mitochondrial DNA is mostly found. I mean, it's possible that it's not from that area, but chances are that it's from this area, this particular river where these ethnic groups all cluster around. I'm often asked, is there any Lucayan Indian DNA found among the current population of the Bahamas? We haven't definitively found any Lucayan Indian DNA, but we do have Native American DNA. There was somebody with ancestry from Nassau. Their direct maternal line goes back to a Loretta Forbes in 1830. And their mitochondrial DNA does not match up with anyone in Cuba, does not match up with anyone in Hispaniola. It matches up with people in Nicaragua, Costa Rica, Belize, Panama. The most likely scenario as to how this is possible is that there is an island off of Nicaragua called San Andreas. And in 1786, San Andreas was given back to Spain, and the British evacuated the colonists to the Bahamas from there. And so the likely scenario is that this is a Mosquito Indian on San Andreas Island. And on a side note is that this family is related to the Farquharson Journal, where in that journal they do talk about Junkanoo. And it's in Belize that we do have the areas of matching here is that we do, there's the British settlements in the West Indies and Central America that they do talk about, they do still have a Junkanoo festival. We've done mitochondrial DNA testing with Bahamians of mostly African ancestry, and you can see the number of different ethnic groups that they're matching up with from various parts of Africa. One of the things that you can do with autosomal DNA testing is to see what parts of your chromosomes are coming from which parts of the world. To zoom in here, we can see that this particular person is mostly of North European ancestry and Western Mediterranean ancestry, and also small amounts of ancestry from other areas in the Middle East and in Europe. I mentioned earlier about the descendant of Loretta Forbes. That was a mitochondrial DNA test, but looking at her autosomal DNA, on chromosome 20, she had a significant portion of chromosome 20 that was American Indian, and that matched up with American Indians, and also Eastern Siberian, and which is the Native Americans came over the Bering Strait from Eastern Siberia to America. Anyone know where this is? Cherokee Sound. Cherokee Sound. It's not photoshopped. This really exists. It's the long dock, and after every hurricane, the community gets together and they rebuild it. It's a very meaningful collaborative effort that the community has done to maintain, and it's basically the mailboat couldn't get all the way to the settlement. They'd take the dock all the way out as close as they could get to the mailboat, and then they would take the dinghy boats to bring things in from the mail to the dock. But what it is an example of collaboration, and that's what I'm going to move into. Is there is a genealogy site that is a collaborative effort to document everyone who's lived on Earth in terms of that we have records for. And it's a way to combine genetics and genealogy. WikiTree is a tremendous, I'm very excited about WikiTree. Most people with ancestry from the Bahamas in the last couple hundred years likely have some shared ancestry, so why not collaborate on our shared ancestral tree? This is a site that allows you to upload photographs of your ancestors or scans of original documents and photographs of grave markings. And so it's a free collaborative one-site tree for the world. There's an honor code, and basically the honor code says that you need to be courteous to other people, you need to be accurate, cite your sources, respect people's privacy, respect copyright. There's 9 million profiles in WikiTree. Probably about 90% of them are unique, and the ones that are not unique, they're trying to merge them together because there's only supposed to be one profile per person. And there are these 9 million profiles have been contributed by 260,000 people, And there's 1,360 really diligent contributors where that they're doing it oftentimes. And then there's about a million new profiles entered every 4 months. So it's growing quite rapidly. And then there's help categories. It's not easy to learn. It's not easy to do at first, but once you learn how, it's not bad at all. And there's help videos and a help category to assist you. And then there's also a tremendous online forum where you can ask any question and you get answers. And because it's a crowdsourced question and answer forum, you can vote up questions and vote down answers. And this helps you figure out whether or not it's a good answer or not. And you get for every question that you ask or any answer that you give, you get points for it. And so you can see who the active contributors are. And what I love about WikiTree is that there's lots of ways to display your information. And this is an example of an ancestral tree with portraits of ancestors. And then you can have an ancestral tree. This is my aunt's ancestral tree in the Bahamas. And this is a tree that you can email to other people. You can just give them the address, the web address for this tree. And it's a live tree that people can see. And if I made a change, then they would see the change happen. And also on here, I'll point out a little bit later, but there's DNA associated with some of these ancestors. And that means that those lines of the ancestral tree have been confirmed with DNA, meaning that I know that it's accurate because distant cousins are matching each other, and those distant cousins have those same ancestors in common. And this is another example of an ancestral tree, but in this case, it goes 8 generations of what I know about 8 generations. If you had a complete 8-generation tree, it would scroll down about 4 more screens. But this is the one that I have for my aunt, which doesn't go back tremendously far. Now, in this, I can also do a descendant tree, a descendant chart that I can email to anyone. So this is the descendants of Matthew Lowe, who was the earliest Lowe known to exist in the Bahamas. And those are his descendants. And this screen actually goes down about, I would say, 7 screens of the descendants of Matthew Lowe that we have in WikiTree. And then you can also do the descendants of Matthew Lowe just on his Y chromosome descendants, those that could have inherited his Y chromosome. And then I can also do the descendants of Wyannie Malone, the woman who helped found Hopetown, and all of her mitochondrial descendants, the ones that she gave to her daughters and the daughters gave to the daughters of the daughters. And then I can do all the descendants of Wyannie Malone who could have inherited her X chromosome. This is somebody, and these are all of their ancestors who she could have inherited her X chromosome from. So whenever you've got an X chromosome match with yourself, you can look at your X chromosome ancestors, email this to your matches and say, do you have any of these matches in your ancestral tree? Everybody in WikiTree has their own profile. You have a web page for every person in WikiTree. And this is my grandfather. In my grandfather's profile, automatically it shows that I took a Y chromosome test. If my 4th cousin, who is a Roberts, takes a Y chromosome test, that fact automatically appears in my grandfather's profile. The important thing is when you take a mitochondrial test or a Y chromosome test, that your results are in a public database. For Y DNA, it's Y-search, and for mitochondrial DNA, it's mitosearch. And you can see that the mitosearch and Y-search IDs of the test takers here on the profile. And if I were to click, now the thing is that how do I confirm that the DNA is showing that the ancestry is accurate? On my grandfather's, there's a DNA confirmation tool where I can see the 2 people in my grandfather's direct male line who have taken a Y chromosome test, and the arrows are pointing to check boxes. And if I check those boxes, and to the right, if I click to compare the results in Y search, then I see the comparison. So this is independent confirmation that these 2 Y chromosome results of distant cousins are matching each other, which confirms the ancestry back to the common ancestor, the most recent common ancestor for that direct paternal line. The same thing is true for mitochondrial DNA and confirming back to the direct maternal line to the most recent common ancestor. When you have got the matching DNA and the genealogy showing you what the shared ancestry is, then you can confirm the ancestry as being accurate. And then the important thing is for every confirmed with DNA that you have a citation where you say that Benjamin is the son of Bob Roberts, his father, and then in the footnote I note how I know that, and I explain that it's the paternal relationship is confirmed by this Y chromosome match, and other people can come later on and verify that that is indeed the case. With autosomal matching, I was mentioning how those overlapping segments, and you need to determine who are the shared ancestors for people that have overlapping segments. Within WikiTree, what you can do is you can find 2 to 5 people and see the shared ancestry of 2 to 5 people. And you can see the multiple shared ancestry. So some people are double cousins of each other or triple cousins of each other. It can also do that. So this is a case where you've got a low matching Roberts, and you can see the relationship trail back to Francis Barnett. I can add a 3rd person, and then I automatically see the shared ancestry of all 3 of those people that had the overlapping segment. I can see how they are all go back to this common ancestor of Francis Barnett. And the other important thing to keep in mind is that you're not sure whether the segment is coming from Francis Barnett or it's coming from her husband. It's coming from a shared couple, but without additional cousins testing, you're not going to be able to determine whether it's which member of that couple it is. And as I mentioned earlier, with the X chromosome with its unusual inheritance pattern, when you've got 2 people matching on the X chromosome, you can just click on the X chromosome ancestors for somebody, for the tester, and share them with your match and say, do you have any of these ancestors in your ancestral tree? And this is somebody, you can see all the various ancestors of somebody from Marsh Harbor and who they're matching. Now within WikiTree, there is, if you put this code in the edit field, if you want to change any information, just at the very top of the profile, you can put this Bahamas code in. What it does is automatically, when you look at the page, it says that this person is part of the Bahamian family and is part of the Bahamas project. And then you can click on the Bahamas project to learn more about that. So everyone who's born, married, or died in the Bahamas should have this code in their profile so that other people can know that this is part of a Bahamian family. There are 2,600 profiles that have that Bahamas code in them. And if you click on Bahamas, then you automatically see everyone who has been coded as being from the Bahamas. Right now, the Bahamas is the 5th highest category in WikiTree in terms of there's the Corleone Italians are number 1, but if we were active, I think we could become number 1 also. The Lowe family from the Bahamas, they trace their ancestry back, one of the few families that can trace their ancestry back to a known pirate. And there is also, so there's a category, just like there's a category for the Bahamas, there's a category for pirates. If you click on pirates, then you get to see all the other pirates that are in WikiTree. And Matthew Lowe is one of those pirates. And then Everyone who's a pirate is also a member of the Black Sheep Society, or the Black Sheep Project at WikiTree. So if you have an ancestor that was a murderer, a traitor, a bigamist, or whatever, you can note them as being a black sheep, and then you can see all the different people that are black sheep within WikiTree. One thing that only recently did I find that we can identify the various loyalists who came to the Bahamas. So if we put in this category up in the upper right, where we've got American Revolution loyalist, you can click that and you can see all the American Revolution loyalists in WikiTree. And so I've done this for Nathan Key, and it can be done for a lot of the other early Bahamian ancestors that we have that are known to be of loyalist ancestry. There's also a very active cemetery project in WikiTree that's very similar to Find a Grave. The thing is that what we discovered in WikiTree early on is that we can't just copy what's in Find a Grave because it's copyrighted. And so because WikiTree is intended to be very shareable, we had to start our own cemetery project. And so this is there's some people that are doing the Key West Cemetery, where a lot of Bahamians are. And so this is and anyone who's interested in cemeteries can become a part of the cemetery project at WikiTree. You can have a profile for a home. From my grandfather's profile, there's a link to this page and of his house. And then there's a box that you can enter information. If you've got a recollection about that particular home or that particular thing, then anyone is welcome to comment on it. And in the bottom left, you can see where somebody has commented on this their memory of the house. And then this is the mailboat that brought my grandfather's family from Marsh Harbor to Nassau. So there's a profile for that boat, the last sailing mailboat from the Abacos to Nassau. And basically anyone who wants to add information that they know about this boat is able to do that. And there you can see the citations at the bottom where the information came from. To talk about the Bahamas DNA Project in general, it was started about 11 years ago in 2004. There are about 190 people that have taken a Y chromosome test and about 107 that have taken a mitochondrial DNA test. And about 78% of them are not from the Bahamas, where they have Bahamian ancestry, but they no longer live in the Bahamas. With the DNA results and the people that are associated with those DNA results, we know that they're from particular islands and particular settlements. So we've got, of all of the descendant charts that we have of the earliest known ancestor and all of their descendants, what their DNA is associated with, most of the association is with Abaco. And then next to that is people in Key West, and then people in Eleuthera, and then Long Island and Nassau. So there's a lot of other islands in the Bahamas that are not well represented in what we've been doing with the DNA testing. And so it's important to remember this is not a scientific survey. It's basically people that quite often it's people that can afford to do the DNA testing. And so a group of Abaconians with living in the United States of European origin, a lot of the people that have tested are of European origin. They don't constitute a random sampling. It would be really good to get more islands included and get more people of African descent, and even to get some people of Greek descent or of Asian descent to participate in the Bahamas project. Of those 107 people that have taken a mitochondrial DNA test, it's revealed that they descend from 49 different women. And almost half of those people descend from just 6 women. So there's just a handful of people that are the ancestors for about half of the white Bahamian population of the Bahamas. These 6 women lived probably in the late 1600s or the early 1700s. What we've discovered is that the Eldon family of the Bahamas and the Sturt family of the Bahamas are one family. And the Pritchards and Kemps may very well be just one family. The Lightbournes share ancestry with a Lightbourne that never came to the Bahamas. Their Lightbourne ancestry is from Bermuda, and the Y chromosome matching is with surnames associated with Clan O'Driscoll in southwestern Ireland. The Clan O'Driscoll lost their land in southwestern Ireland about the same time as the Lightbournes show up in Bermuda. Then there's a Jones in the Bahamas who was a lighthouse keeper, and he's matching up with the Humphreys in colonial America. There was a Jones who was an apprentice of the Humphrey family in colonial America also. And there are, through the historical record, it's suspected that there are 4 different Russell families in the Bahamas. We've tested 3 different Russell lines, and they all match each other. Those 3 Russell lines cannot connect their genealogies, but they're all one family with a shared ancestor who likely lived in the Bahamas. So basically, if you've got an ancestry going back 300 years in the Bahamas, we're probably all related somehow to each other. Thank you all very much.
Thank you.
No quizzes, no quizzes. But if you want, you can take a DNA test.